In this age of artificial intelligence, we have had so many models this year. From the most widely used ChatGPT to Llama 2 by Meta to be used by developers. Google, after launching Bard, is set to work on another AI model that is set yet to be launched. This new model is said to be so strong that ChatGPT would be of no match for it. Google is working on Gemini. Google's aim with Gemini here is to take different features of AI and integrate them into one model. This will make it a jack-of-all-trades kind of versatile AI model. Unlike the other models out there, which are good at only one kind of task or data type, with Gemini, you'll be able to do all of those tasks combined. This AI won't have any limitations when it comes to data types. This has the potential to change how we use Google's search engine. Imagine being able to do a lot more on the search engine than just getting a boring screen of text. With Gemini integrated with Google, you will be able to do things other than searching the web, like creating videos, or even turning spoken words into images. And the best part is you won't have to rely on any other tool. Right now, when we use a search engine, we get nothing but a search bar to type our query into and hundreds of web pages to click on. With Gemini, things will be a little different. You'll enter a text and you will get a more dynamic web result. Along with a text-based response, imagine yourself getting a video or audio response. You'll be able to do a lot more with this. If you need to create content in the form of video or audio, Gemini will be there to help you out. Gemini is part of a broader Gemini project. Want to know where Gemini came from? This came from a grand scheme by Google called the Gemini Project, which was undertaken by Google's DeepMind and is known for its groundbreaking work in the field of artificial intelligence, especially after its success with AlphaGo. Remember that AI that wiped the floor against a real human in a Chinese board called Go Back in 2016? That was this exact AI model. This project is another initiative by Google to create another model that can be used as a universal AI system. Google wants a system that can do more. Google's primary goal for Gemini is to develop a universal AI system. This means the AI system has to be able to work on a wide range of tasks across different domains. Meaning they don't want a system that specializes in just one domain. The system must be able to handle tasks related to natural language understanding, image recognition, problem solving, and more. This versatility makes it suitable for more types of applications. Different techniques used to make this model work. One of the techniques used here is reinforcement learning. What happens here is that the AI learns by interacting with its environment and receives feedback every time. This can either be in the form of a reward or a penalty, telling the model what to and what not to do. Gemini uses this to improve its ability to perform tasks over time. It learns from its past actions and adjusts its behavior to maximize rewards and minimize penalties. Gemini relies heavily on feedback to improve itself. This feedback can come from anywhere, may it be from a user or from any other external source that helps the AI learn from its mistakes and improve its responses. In the case of Gemini giving an inaccurate answer to a user's query, the feedback from the user can help it correct and refine its responses in the future. Tree search is a technique that is commonly used in game-playing AI like the AlphaGo. What happens here is the AI starts exploring different possible outcomes and actions in a branching tree-like structure to figure out the best course of action. In the context of Gemini, tree search can be used to explore possible responses and actions, allowing the AI to select the most appropriate one based on the context and user input. When these three techniques are combined, Google can easily develop a system that can effectively process and generate text, images, videos, and audio content. Motive behind Google's investments. Google sees a huge potential in this piece of tech and wants to improve its current tools and products. One product is its chatbots. If Google can integrate Gemini into these chatbots, they will instantly get a lot more powerful and be able to handle different kinds of data. Google also wants to enhance its search engine. This is one of the most, if not the most widely used search engine ever to exist, and Google relies heavily on AI algorithms to give you results. Add Gemini to it, and you'll see the search engine enhanced to give you a more comprehensive and accurate response to your queries. Every AI model's efficiency depends on one thing, and that's how much data you provide to train it. Google seems to have that covered since it has a huge pool of data for Gemini to train it from. This data comes from Google searches, YouTube, and other Google sources. MIT and Harvard introduced FAN recently with the combined efforts of Harvard and MIT. Researchers came up with Follow Anything, or FAN for short. What it does is allow robots to track objects in real time using a simple camera and straightforward queries. FAN is built over the architecture of a transformer. Transformers are well known for their effectiveness in natural language processing tasks like language translation and text generation. Researchers took this architecture and went crazy with it. They came up with a way to use this architecture and make it understand images. How FAN is different. Unlike other tracking systems that use CNN networks, which are quite complex, since they need to go through the complicated code of establishing a bounding box and a mask to keep track of an object. The thing is that object is set constant and can't be changed easily. If you do need to change the object to track, you'll have to train the model again and manually tune the model. FAN simplifies this masking process by using VITS, and all it needs is a bounding box to initially identify the object of interest. This makes it a lot more user-friendly. You can guide it to recognize and track new objects by using plain language descriptions, showing a picture of the object, or even clicking on the object within the video stream. FAN can also track multiple objects simultaneously, with users providing separate instructions for each object they want to track. This means that it can handle complex scenarios where multiple objects are moving in the video. FAN has proven to give a robust performance in terms of accuracy and can handle all those little issues with objects like going out of view, fast object motion, and disturbances in the background. FAN has even shown its promising learning capabilities by being able to work on different datasets without any extra training. All these things combined make it suitable for real-world applications. FAN is available for the public. What makes FAN even better is that it's not a proprietary technology restricted to a select group of users. The researchers have made the code and models for FAN available to the public to encourage more collaboration and development of the system by a broader community. Their aim is to use FAN in robotics and computer vision. This opens up the possibility of robots and systems that can interact intelligently with various objects in different environments. For instance, it could be used for robot assistants, automated cleaning robots, or even for tasks like playing games and exploration. Do you think FAN and Gemini will surpass all the other AI models out there? Let us know in the comments section below. If you enjoyed today's video, then make sure to leave us a thumbs up, and do not forget to subscribe to our channel and click on the bell icon to be always updated with the most exciting content as soon as it's uploaded. Thanks for watching. See you again soon in another video.